There's a clock counting down right now and nobody's watching it. It isn't on a wall. It isn't on your phone. It exists in a set of calculations sitting in a building in Pasadena, California, and it points to one exact moment, not a rough date, not sometime this year, an exact second. 2:16 and 7 seconds in the morning, Pacific time, on November 18th, 2026. NASA knows this moment down to the second because they can calculate it. And once you hear what happens when that clock hits zero, you are going to understand why a handful of scientists have been quietly watching this date approach for years. I'm not going to tell you what it means yet, just hold on to it. A clock, an exact second. Something ends, or maybe something begins, right at that moment. Stay with me, because by the end of this video, you'll know exactly what happens when that number hits zero, and it is stranger than anything you're picturing right now. Welcome back to the Space Frontier. If you're new here, this is the channel where we take the strangest, most underreported stories in space science and actually explain what they mean, without the fluff. And this one, I promise you, is one of the best stories we've ever covered. So if that sounds like your kind of thing, go ahead and hit subscribe right now. Because we're about to go somewhere most channels won't take you. And you don't want to miss what's coming in the next few minutes. Let's rewind. Not to last year, not to last decade. Back to 1977, before most of the people watching this were born, before the internet, before cell phones, before home computers were a normal thing to own, a rocket lifted off from Kennedy Space Center in Florida, carrying a spacecraft that nobody expected to matter much beyond a few years. Its name was Voyager 1. Its job was simple. Fly past Jupiter, fly past Saturn, take some pictures, collect some readings, and that's it. NASA engineers built it to last 4 years. Maybe 5 if they got lucky. Nobody planning that mission in 1977 thought they were building something that would still be working, still be flying, still be making headlines 49 years later. But that is exactly what happened, and the story of how it gets stranger the further you go. Voyager 1 reached Jupiter in March of 1979 and sent back the first truly close images humanity had ever seen of that planet. Then it swung past Saturn in November of 1980, using the planet's own gravity like a slingshot to fling itself even further and faster into the outer solar system. And here's where most people expect the story to end. Job done, mission complete, let it drift off quietly. Except it kept going. It kept transmitting, kept sending data back across a gap that grew wider every single day. And attached to the body of this spacecraft is something almost more remarkable than the mission itself. A gold-plated copper disc, designed with help from the astronomer Carl Sagan, carrying greetings recorded in 55 human languages, the sound of ocean waves, the sound of human laughter. 90 minutes of music pulled from cultures across our entire history as a species, and a map showing exactly where our planet sits in the galaxy. Sagan once described it as a message in a bottle thrown into the cosmic ocean. Think about that phrase for a second, because you're going to want to remember it later in this video. A message in a bottle, something meant to be found by someone someday who has no idea we ever existed. Now here's the moment where everything changes. In 2012, 35 years after launch, Voyager 1 crossed something called the Heliopause. If you've never heard that term, here's the simplest way to picture it. Our sun doesn't just give off light and heat. It constantly releases a stream of charged particles, and that stream blows outward in every direction, forming a massive bubble around our entire solar system. Every planet, every moon, every spacecraft we've ever launched, everything sits inside that bubble. The edge of it, the exact point where the sun's influence finally runs out and interstellar space takes over, that's the heliopause. And in 2012, Voyager 1 punched straight through it and came out the other side. It became the very first object built by human hands to leave the solar system entirely. Not metaphorically. Actually, physically. It is sitting right now in the space between stars. Now pause and actually sit with that, because I don't think it gets the reaction it deserves. We have a machine, built with 1970s technology, that is currently inside interstellar space, sending us information about what that environment is actually like. No telescope has ever done this. No satellite, no mission to Mars or the asteroid belt. Just this one machine, alone out there, older than most of the people who currently operate it. And what it found once it got there did not match what anyone expected. Before Voyager 1 crossed that boundary, scientists had spent decades building models to describe what interstellar space should be like. Serious, peer-reviewed, carefully tested physics. And almost all of those models agreed on one thing. Interstellar space should be quiet, thin, calm. A cold, sparse nothing between star systems where not much happens. A researcher at Cornell named James Cordes, who's worked closely with this data, described the interstellar medium in a much more human way. He compared it to a quiet, gentle rain, occasionally interrupted by storms kicked up from our own sun. That's a beautiful image, and it's also more accurate than the version most people imagine, which is a total, silent void. Here's your first curiosity loop, and I promise we come back to it. Because starting in 2017, an instrument on board Voyager 1 called the plasma wave system started picking up something nobody was expecting to find at all: a faint, narrow, continuous hum. Not a burst, not a one-time spike, a signal that has now persisted for years, stretched across hundreds of millions of miles of interstellar space, and scientists still aren't completely certain what's causing it. Hang on to that, because we're going to answer it properly in a few minutes, and the answer is stranger than you'd expect. But before we get there, I want to tell you about the moment this entire mission almost ended for good, because it happened far more recently than you'd think, and almost nobody outside the small team running this spacecraft knows the full story. In 2023, Voyager 1 started sending home gibberish. Not silence, something almost worse than silence. A signal was still arriving, loud and clear, but the information packed inside it made no sense at all. Corrupted, scrambled. For engineers who had spent decades learning to read every quirk of this specific machine, this was something entirely new. For 5 months, they didn't know if the spacecraft could ever be recovered. When they finally traced the problem, they found a single memory chip, a tiny piece of nearly 50-year-old hardware, had degraded after decades of constant exposure to cosmic radiation out in deep space. One small failure in one small chip, threatening to end a mission that had already outlived its expected lifespan by a factor of 10. And here's the part that makes this genuinely wild. There was no way to send someone out to fix it. The spacecraft sits so far away that a radio signal traveling at the speed of light takes about 22 hours just to arrive. Then another 22 hours for any reply to come back. Every single test, every attempted fix, took nearly 2 full days just to see if it worked. Engineers at NASA's Jet Propulsion Laboratory spent months essentially performing surgery on a machine 15 billion miles away, one incredibly patient step at a time, knowing a single wrong command could end everything permanently. And they pulled it off. They found a way to relocate the corrupted code to different parts of the spacecraft's remaining memory piece by piece until it worked again. By 2024, Voyager 1 was back online, transmitting clean data again, and almost immediately, it started sending back more of that strange, unexplained hum from interstellar space. Now, let's actually answer that curiosity loop, because this is where the story gets genuinely important, not just interesting. That persistent signal, detected since 2017, gives scientists something they've never had before: a continuous, ongoing measurement of the density of interstellar plasma, instead of the old method, which relied on rare, random shock waves from our own sun rippling outward and occasionally triggering a brief, detectable spike. This new signal is different. It's steady. It's ongoing. It's the closest thing to a live feed of interstellar space that has ever existed. And researchers studying it have identified 2 possible explanations for what's actually producing it. One possibility is that it comes from naturally occurring plasma oscillations, something that would fit comfortably inside existing physics. The other possibility is something called quasi-thermal noise, a different mechanism entirely, one that would mean our current models of interstellar space need real revision. And here's the honest truth that most videos on this topic won't tell you. Scientists don't know yet which explanation is correct. This isn't a mystery that's already been solved with a dramatic reveal. It's a live, open question, sitting right at the edge of what we understand about the universe beyond our own solar system, and the only way to answer it is with more data from this exact aging spacecraft. Or an entirely new mission that doesn't currently exist and wouldn't reach interstellar space for at least another 25 years, even if funding started today. Sit with that for a second. The only real-time window we have into the space between stars is a machine built before most currently working. Physicists were born, and there was no backup plan. Now, before I bring this back to that clock I mentioned at the start, I want to clear something up, because a lot of videos covering this topic get an important detail wrong, and it's worth understanding correctly. You'll often hear that Voyager 1 runs on just 4 watts of power, framed like the entire spacecraft survives on less electricity than a small light bulb. That's not quite accurate, and here's the real version. Voyager 1's power comes from radioisotope generators that convert the natural decay of plutonium into electricity. At launch, those generators produced around 470 watts. Today, after 49 years, that output has dropped to roughly 250 watts, and it keeps declining by about 4 watts every single year. The actual radio signal Voyager 1 transmits back to Earth carries only about 23 watts of power, an incredibly faint whisper by the time it crosses 15 billion miles of space and reaches the giant dish antennas of NASA's Deep Space Network. So it's not that this machine survives on 4 watts total, it's that it loses about 4 watts of its total power every year, and eventually, sometime in the early 2030s. That decline will cross a threshold where there simply isn't enough power left to run any instrument at all. NASA already knows this is coming. They've spent years deciding, one instrument at a time, what to shut off and in what order, because every instrument they power down is a set of scientific questions that will never be answered, and there's no way to switch one back on once it's gone. Now here's where everything comes back together, because that clock I told you about at the very beginning of this video is about to make perfect sense. On November 18th, 2026, at 2:16 and 7 seconds in the morning Pacific time, Voyager 1 will reach a distance of exactly 16,094,799,096 miles from Earth. NASA has calculated this number down to the individual mile and the individual second, because at that exact distance, Voyager 1 becomes the first human-made object in history to sit a full light day away from home. That means a radio signal, moving at the fastest speed physically possible in our entire universe, will take a complete 24 hours just to reach it. Send it a message on Monday morning, and you won't know if it arrived until Tuesday morning. You won't hear anything back until Wednesday. That's not science fiction. That's an actual communications reality NASA engineers are planning around right now. And that's the clock. That's what's counting down. Not an ending. Not exactly. Something closer to a threshold. A line no human-made object has ever crossed before, being crossed for the first time, by a machine that was only ever supposed to last 5 years, using technology that predates the personal computer. Here's what I think is the most important part of this entire story, and it's the part most people miss completely. Voyager 1 will keep moving after its power runs out. There's nothing out there to slow it down. No air resistance, no friction, nothing strong enough to meaningfully pull it off course. It will simply keep drifting in a straight line, silently, forever, at roughly 38,000 miles an hour. Long after the last engineer who ever worked on this mission has passed away, long after every human record of this mission might be lost to time, and it's not heading toward nothing. In about 40,000 years, Voyager 1 will pass reasonably close to a star called Gliese 445. It won't stop there. It won't be seen there, but it will pass by, carrying that gold-plated record, that message in a bottle Carl Sagan described decades ago, still intact, still readable by anyone or anything that might one day find it, long after every trace of the people who built it is gone. Think about what that actually means. Right now, in 2026, the only functioning scientific instrument humanity has ever placed in interstellar space is nearly 50 years old, running on power output smaller than a light bulb, and it is quietly rewriting what we understand about the space beyond our solar system. We've built bigger telescopes. We've built more powerful satellites. We've spent far more money on newer missions. None of them have told us what this one aging spacecraft is telling us right now, because none of them are actually there. None of them made the trip. Voyager 1 is the only machine that had the patience, or maybe the luck, to keep going long enough to actually arrive. And soon, in the early 2030s, it's going to go quiet, maybe forever. There's no confirmed replacement mission. Nothing currently funded that could reach interstellar space and pick up where this one leaves off for at least another quarter century. Which means whatever Voyager 1 is still trying to tell us in these final years, we need to actually be paying attention, because once that signal stops, this exact window into the universe closes, and it may not open again in most of our lifetimes. So here's what I want to know from you. When that clock hits 0 on November 18th, and Voyager 1 crosses a full light day from Earth for the first time in human history, what do you think it should be listening for in its remaining years? Drop that in the comments. I genuinely want to see what you think, and while you're down there, tell me what part of this story surprised you the most, because I read every single one of these. And if this kind of story is exactly what you come here for, do me a favor and share it with one person who'd appreciate it, because stories like this deserve more attention than they usually get. Subscribe if you haven't already, because we've got more stories like this coming, and trust me, some of what's next is even stranger than this. Thanks for watching The Space Frontier, and I'll see you in the next one.